guys, it's Miss Fish. I am back to talk to you about pH. So if you look at your Cornell notes, we have a couple things that we're going to cover today. Before we begin, I'd like to tell you that we're not going to dive that deep into pH. You'll dive deeper into it when you take chemistry. But I just want to go over the basics and basically inform you of what the scale means, and because we're going to be talking about it later in the year. So pH, little p, capital H, that's how you write it. No ifs, ands, or buts about it. If you don't write it with a little p and a capital H, it's wrong. So, pH, what does it mean? pH means parts of hydrogen. It measures how many hydrogen atoms are in a solution. A high number of hydrogen atoms means a low pH. Okay, so if we have a concentration, if we're given a concentration of a solution and it has a larger number of hydrogens, then we're going to have a low pH. When we have a lower pH, that means it's going to be more acidic. If we have a low number of hydrogens, that means we're going to have a high pH, and that's because it's going to be more basic. Okay, so when you're looking at a solution, pH is measuring the number of hydrogen atoms that are found in the solution. Go ahead and pause and finish writing what's on the slide if you need to before moving on. The pH scale is your next main idea or key idea. The pH scale is based on a logarithmic scale. So, for example, if we were going to do the math, what we would do is we would say pH is equal to the negative log of the hydrogen concentration. So we would be given the concentration of hydrogens, and we'd put it in that formula, negative log, parentheses, number, end parentheses, and hit equal on our calculator, and we would get the pH. We're not going to worry about doing that math. I just want you to know that you are using a negative log. Since we're using a negative log, this means that each 1 unit change on the pH scale, for every 1 unit change on the pH scale, the hydrogen concentration increases or decreases, depending on which way you go, tenfold. So, let's say I go from a pH of 1 to a pH of 2. I go from something very, very, very acidic to something that's just very, very acidic. So, my concentration of hydrogen atoms decreased tenfold. If I had a pH of 14 and I go down to a pH of 12, I move 2 spaces along the pH scale. So therefore, my pH will increase 20 times, 20-fold, because I moved 2 spaces. So instead of just 10 for 1, I did 10 times 2, gives you 20-fold. The scale goes from 1 through 14. Number 1 through 6 are acidic, 7 is neutral, and 8 through 14 is basic. If you need a moment to finish writing, go ahead and pause the video and finish writing before moving on. Next, we're going to talk about the different parts of a pH scale. So we have your acids, bases, and neutral substances. Acids are found on the pH scale from 1 through 6. So anything in that range, 1 through 6, is considered an acidic substance. They have a higher concentration of hydrogen atoms. Some examples that you might be aware of are lemon juice, coffee, battery acid, and vinegar. Those are all examples of acids. We can consume acids. We consume lemon juice, we consume coffee, we can also consume vinegar if you put it on if you have vinegar chips or on your fries. But if we were to ingest battery acid, it is too acidic. It would really, really hurt us. So some things we can't ingest, but some we can. Moving on to bases. So bases are found on the pH scale from 8 through 14. They have a lower concentration of hydrogen atoms, and some common examples include bleach, antacids, and other cleaning agents. So antacids is something that you might take if you're having heartburn. Heartburn is just the increase in stomach acid in your stomach. You take the antacid and it calms your stomach because it neutralizes some of that acidicness in your stomach. All right, moving on to neutral substances. Neutral items have a pH of 7. They have equal parts hydrogen, which is represented by an H+, and hydroxide atoms, represented by OH negative. Okay, so hydrogen, that's pretty easy to remember. We have hydrogen, H+. We have hydroxide. So since we have the hydroxide, we have the H. And then we have the O for oxide. Okay, and a negative symbol. So hydroxide always has that negative symbol up there in the corner, and hydrogen always has that plus sign. If you also think about, we live in Ohio, and how everyone goes OH, and you go IO. So that might help too. That was something that I kind of used in my when I was younger. And a common example is water. Go ahead and flip your paper over if you're finished writing. If not, go ahead and pause. But if you're done, go ahead and flip your paper over. I want you to look at something on the back. So on the back of your paper, you have a pH scale. This one uses the number 0, which is fine. Our scales will probably typically go from 1 through 14. So down here is the most acidic things. And then as you go up the pH scale, it gets more basic and the numbers gets higher. So down here at this end, where the 1 and the 0 are at, we have things that have higher. We have things that have a higher hydrogen content. Okay, so they have more hydrogen atoms. If we move up the scale to numbers 13 and 14, that means we have less hydrogen atoms. Okay, so as we increase to 13 and 14, we have less hydrogen atoms. As I decrease, so if I go from 14 to 13, 12, and 11, I start increasing my hydrogen atoms, okay, and they increase tenfold. So from 10 to 14, I get 10 more. So if I were to go if I start here, let's say I had 1 concentration of one hydrogen, so then I'd go to 10 hydrogen, and then 20 hydrogen, then you just keep, sorry, not 20, excuse me, 10, from 14 to 13 is 10, from 13 to 12 is 100, from 12 to 11 is 1,000, so you just keep on going tenfold, okay, so you basically add a 0 at the end of each number, and that's how it increases or decreases, okay? If you have any questions, please don't hesitate to ask me before class or after class. Please make sure you write the summary at the bottom of the front page, and I hope you guys have a great day. Thanks. Bye.